Sum number 8, which is of 3 marks. Sum of 1 to n natural number is 36. So given is 1 to n natural number. So the given sequence of natural number in AP is 1, 2, 3, 4 till n, because 1 to n numbers. Find the value of n if sum of the natural number n natural number is 36, such that S of n equal to 36 sum of natural numbers. Which, how many natural number? N natural number, because it is 1 to n is 36. So S of n is 36, and find the value of n. To find the value of n. Solution. Now solution. S of n is given for NAP, for NAP. The sequence of natural number is 1, 2, 3, 4 till n. Therefore, first term equal to 1, common difference equal to 2 minus 1, which is 1. Now, since S of n equal to n by 2 into 2a plus n minus 1 into t. This is nothing but the formula. S of n, we know the S of n is 36. And we need to find n by 2, 2a. N is 1, and we need to find minus 1 into difference is also 1. Substituting values. Now 36 into 2 equal to n, 2 into 1, 2, plus n into 1, n minus 1, that definitely it is not possible, so into 1, so remain n minus 1. Therefore 36 2s are 72 equal to n, 2 minus 1, 2 minus 1 is 1 plus n. Just multiplying, 72 equal to n into 1, 1n plus n into n, n square. Now n square, 72 will go there, n square plus n, n means 1n, minus 72 equal to 0. This means make two part of 72, standard 9th, factorization. Make two part of 72 whose difference. Now what do you mean by difference? Difference means different sign. Difference means different sign. So one sign will be plus and the other will be minus. Here we need difference as plus 1n, so we need plus, so bigger number will be positive, smaller number will be negative. So I'll repeat, make two part of 72 whose difference means different sign, is plus 1. That's why first number will be positive, the second number will be negative. Now we need to make two part of 72 whose difference is plus 1, and that part are 9 8s are 72, 9 8s are, so bigger number will write first, smaller number we will write later on. Okay, and the n will come in starting design variable. So the factors will be n plus 9 and n minus 9. So factors are n plus 9 and n minus 9 n minus 8 equal to 0. Therefore n plus 9 equal to 0 or n minus 8 equal to 0. Hope you remember this you have learned in standard 9th. Now n equal to minus 9 or n equal to 8. As we know, the number of numbers cannot be negative here because they are natural numbers, and even the nth term cannot be negative. Like you cannot say minus ninth term. You can say first term, second term, third term, fourth term, fifth term, 100th term, but you cannot say negative terms, right? So this is incorrect. As n equal to minus 9 is not possible, therefore it is discarded. Therefore only n equal to 8 is accepted. So how many terms are there? We need to find the value of n. N is 8. Therefore the value of n is 8. Full stop. Sum number 9, which is of 3 marks. Divide 207 in 3 parts such that all 3 parts are in AP. When 3 parts are in AP, so let 3 parts of 207 which are in AP be, we know what are the 3 parts in AP: A minus D, A and A plus D. A minus D, A and A plus D. Now as they are part of 207, 3 parts of 207, so again when we add them it will become 207, because when 207 is divided into 3 parts, and when we add all that 3 parts we will again get 207. Therefore A minus D plus A plus A plus D equal to 207. Now minus D plus D will get cancelled. A plus A plus A is 3A. 3A equal to 207. A equal to 207 upon 3. Therefore A equal to 3 6 are 18, 3 9s are 27. So A equal to 69. Now as we got A equal to 69, we'll make it a box. Now it is given that product of 2 smaller parts is 4 6 2 3. Smaller 2 parts are these. As product of 2 smaller parts is 4 6 2 3. Therefore A minus D into A equal to 4 6 2 3. Now A minus D is 69 minus D into A is 69 equal to 4 6 2 3. Now first this multiplication, 69, this 69 will go in denominator on other side. 69 minus D equal to 4 6 2 3 upon 69. Now we will divide. 69 and 4 6 2 3. 2 digit, but this 2 digits are less, so 3 digit. 69 is very close to 70, right? 70. So we will say the number of 7. As we are assuming it is 70 and we are hiding 0, last digit, and we are telling that it's a table of 7. Same here, we need to hide last digit, which is 2. We will say, sir, 3 is the last digit. Here we have underlined only 3 numbers, and in 3 numbers the last digit is 2. So you need to hide 2. Here you have hidden 0. So 7 table till 46. 7 6 are 42. Right? 7 7s are 49. 49 will be greater, so 6 are. So mostly it will go by 6. Now 6, you don't have to multiply with 70 because 70 we have assumed. 6 you have to multiply with 69 itself. So 6 9 6 are 54. 5 6 6 are 36. 36 and 5 41. So 414. 12 minus 4 is 8. 5 minus 1 is 4 and 4 minus 4 is 0. Next number carry forward is 3. Again 7 6 are, so we know 4 1 4, 7 7s are, mostly now this time 7 will come. 49, but it is very near to 49. Now 7 9s are 63, so 3 and 6 will come. 7 6 are 42, 42 and 6 48 will come. See, it is correct. So answer is coming 67. So 69 ones are 69 67s are. So 69 minus D equal to 67. Now D will go there. Minus D will become plus D. 69 67 will come on this side. It turns into minus 67. So D equal to 2. D equal to 2. So we got A as well as D. Now we will get all three parts. Therefore first part A minus D, which is 69 minus 2, and that is 67. A equal to 69 and A plus D equal to 69 plus 2 equal to 71. Therefore 3 parts of AP are in AP are 67, 69 and 71. This is the answer. Sum number 10, 4 marks. There are 37 sums in an AP. The sum of 3 terms placed exactly at the middle is 225. It means, example, if there are 37 dots, there will be 3 terms which are placed in the middle. 3 terms which are placed exactly in the middle. So we need to find which terms are these. For that, there is a formula for middle term. Middle term equal to, now for that total terms, you should know total terms. Total terms in AP equal to 37 terms are there, which is odd. And hope you remember statistics of standard 9, the middle term, that is called median. For odd, middle term will be odd number, that is 37 plus 1 upon tooth term, which is 38 upon tooth term, which is 19th term. So exact middle term is 19th term. But we need to find 3 middle term placed exactly at the middle. So 3 middle terms, therefore 3 middle terms are T18, T19 and T20. Definitely 19th is the middlemost term. So the adjacent terms will be T18 and T20. So middle terms are T18, T19 and T20. Such that T18, now what they have told, the middle term is 220, sum of the middle term is 225. So T18, T19 plus T20 equal to 225. Right? Since T of n equal to A plus n minus 1 into D. This is formula. Therefore, T18, what will is T18? T18 will be A plus 18 minus 1 into D. T19 will be A plus 19 minus 1 into D. And T20 will be A plus 20 minus 1 into D equal to 225. A plus 17D, A plus 18D, A plus 19D equal to 225. 3A plus 18 3s are 54D equal to 225. Now 5, 6, 7, 8, 9. Okay, these all terms are divisible by 9. Sorry, 3, divisible by 3 because it is 3. So divide throughout by 3. So a plus 3 ones are 3, 3 6 3 8s are 24. D 18D equal to 3 7s are 21, 3 5s are 15. Divide throughout by 3. So a plus 18D equal to 75. So a equal to 75 minus 18D. Mark it 1. So we got the value of a now. 75. This is a tentative because the variable is still there. Now next is given the sum of last 3 terms. Sum of last 3 terms. Last 3 terms are 3 terms are t total terms are 37. So 35, 36 and 37, such that their sum is 429. T35 plus T36 plus T37 equal to 429. What is T35? A plus 34D. But now we have to write full 35 minus 1 into D. T36 is A plus 36 minus 1 into D. T37 is A plus 37 minus 1 into D. That is 429. A plus 34D, A plus 35D, A plus 36D equal to 429. So 3A, 35 3s are 105. So 105D equal to 429. We know the value of A. So I'll substitute value of A here. So 375 minus 80D plus, or is wait, let me see whether it is something is common or not. 3 is common, 4 6 yes, 3 is common. So first we will take what we say, take out 3 as a common. So A plus 3 3s are 9, 3 5s are 15, 35D equal to 3 1s are 3, 3 4s are 12, 3 3s are 9, 143. Divide throughout by 3. Now we can substitute the value of A. A is 75 minus 18D plus 35D equal to 143 from 1. Now 75 will go there, minus 18D plus 35. 35 minus 18 is 17D equal to 143 minus 75. So D equal to 13 minus 5 is 8. 13 minus 7. 13 minus 7 is 6, 68. And 17 will go in denominator. So D will be D equal to 17 4s are 68. D equal to 4. So we got the value of A. No, we haven't got value of A. Now we'll substitute D equal to 4 in equation 1. Substitute value of D equal to 4 in equation 1. And first equation was A equal to 75 minus 18D. 75 minus 18 into 4. 75 minus 72. And that is 3. So A we got as 3. So we got first term, write an AP. We need to write an AP. AP means at least 4 sequence and then dot. So to write an AP, the first sequence, so therefore A equal to 3, that is first term. Then second term, A plus D which is 3 plus difference was 4 equal to 7. Third term, second term plus difference, that is 7 plus 4 equal to 11, and so on. But we know there are total 37 sums. It was there in a question. There are how many terms? 37 terms. So we need to find last term as well, because that will be the real AP. Here the AP is ending at 37 terms. Since T of n equal to a plus n minus 1 into d, this is formula. Therefore T of 37, that is last term, a we got 3, 37 minus 1 into difference. What is the difference? Difference is 4. 3 plus 37 minus 1, 36, and 36 4s are 144. 144. So 144 plus 3 is 147. So T37 is 147. That is the last term. Therefore, the terms in AP are, the first is 3, 7, 11, dot till 147, and this is the answer. Now sum number 11, which is of 4 marks. This sum is quite easy, but you have to be very neat while solving it. If you make even a single mistake, then you will mess up everything. So let's start with sum number 11. If first term of an AP is A, second term is B, and the last term is C, in such scenario, in such case, the sequence, or I'll write as per given information. The sequence in AP is A, B, dot and last term is C. Show that sum of all terms is this. So show that, to prove. Show that means to prove. We need to prove that sum of all numbers S of n is A plus C, B plus C minus 2A, the whole upon 2 under bracket B minus A. Now proof. First we'll write in an AP, A, comma B, comma dot C. This is called first term. So T1 equal to A, first term. Difference, comma, difference is B minus A. Difference is B minus A. And the last term is called T of n. And T of n is C. I'll repeat, this is called first term, right? This is called second term, so difference will be B minus A. And this is called last term, and last term is T of n. Now since we'll find out the value, we need to find out sum of all the terms in AP. So first, before that, we'll find out the value of n. Since T of n equal to A plus n minus 1 into D, this is formula. T of n we know it is C equal to first term. First term is A itself, so it will remain A. And we need to find minus 1 into difference is B minus A. So first A will go there because we are multiplying this, so I'll put it under bracket. A will go there, A will go there, so it becomes C minus A equal to n minus 1 into B minus A. Now this B minus A will go in denominator. This B minus A will go in denominator. So C minus A upon B minus A equal to n minus 1. Now again C minus A upon B minus A, minus 1 will come on this side. It turns into plus 1 equal to n. Right? Now therefore n equal to just cross multiplication LCM. 1 into C minus A plus 1 into B minus A upon 1 into B minus A. So in alphabetical order, minus B minus A minus 2A plus B plus C the whole upon B minus A. This is the value of n. Or you can change. We generally don't write negative term first, so you can write B plus C minus 2A upon B minus A. This is the value of n. Now since S of n, because we need to prove sum of number is this, S of n formula is n by 2. We know the first term and the last term. Remember, we know the first term and last term. What is the first term? A. What is last term? C. So we'll use that formula. S of n equal to n by 2 into first term plus last term. This is formula. Now S of n, and what is the value of n? Value of n is this. So B plus C minus 2A upon B plus A. This is value of n. The whole upon 2. And 2 upon nothing is there, so 1. 2 upon 1. Are you getting it? Whole upon 2. This whole upon 2. But we don't want 3 terms. So the fourth term will come upon 1. Into. What is the first term? T1. What is T1? A. Plus. And what is the last term? C. Now it is very simple. S of n. You just need to reciprocal, because whatever will come in denominator, it will get reciprocal. So B plus C minus 2A upon B plus A into 2 upon 1 will get reciprocal. It becomes 1 upon 2 into A plus C. Now just you have to arrange as required. What we need? A plus C. We have A plus C into B plus C minus 2A into B plus C minus 2A, because A plus C into 1 remains A plus C. B plus C minus 2A. So B plus C minus 2A upon 2 under bracket. Now B plus A, and we need B minus A. B minus A. I think I had made a mistake. Here B minus is there, and while substituting I wrote by mistakenly B plus A. So kindly you don't make such mistake, otherwise it will cost you more. Are you getting it? So B minus A, here also B minus A. It's good that it is proof, right? So you can always verify whether you are getting same answer or not. So now it's correct. So B minus A, and we have corrected this thing. So hence proved. Then this is the end of 11th sum, which is of 4 marks. Sum number 12, which was asked in March 17 paper, and it is of 4 marks. If the sum of first P terms of an AP is equal to sum of first Q terms. So we will be writing now given first. So given sum of P equal to sum of Q, because sum of first P terms equal to sum of first Q terms in an AP. Show that. It means we need to prove. So to prove that sum of first P plus Q terms, that is sum of P plus Q terms, is 0 where P is not equal to Q. So it is also given, so we will write in given AP where P is not equal to Q. To prove, the next will be proof. In an AP, now you can see every time there is S of P, S of Q, or S of P plus Q. In short, every time there is sum of certain numbers. Terms of number is not asked. So we will not use term formula, we will directly use sum formula. So in an AP, S of n equal to n by 2 into 2a plus n minus 1 into d. This is formula. Right? We need to find S of P, S of Q and S of P plus Q. S of P plus Q. Therefore, S of P equal to P by 2 into 2A plus P minus 1 into D. We'll mark it as 1. And S of Q equal to Q by 2 into 2A plus Q minus 1 into D. We'll mark it as 2. And S of P plus Q equal to P plus Q, as it is binomial, it is preferable to put under bracket. So P plus Q upon 2 into 2A plus Q minus 1 into D, and mark it as 3. So we got all S of P, S of Q and S of P plus Q. Now since it is given that S of P equal to S of Q, since S of P is equal to S of Q, which is given, so S of P formula is P by 2 into 2A plus P minus 1 into D, and S of Q will be Q by 2, that is here, into 2A plus Q minus 1 into D. We got it from 1 and 2. So from 1 and 2. We know that in denomination or in denominator 2 is there on both the side, and which is in multiplication form. So this 2 and this 2 will get cancelled. So the number left is only P into this all and Q into this all. So right now I will not multiply, I will just P as it is, and 2P, 2A plus, now we will multiply this thing. P into D is PD, but I would prefer not to write PD, write DP. Write in alphabetical order, it will be less confusing to you. So follow certain laws and patterns. So here the laws are D into P, it's a DP, minus D ones are D, equal to Q will remain Q, 2A plus DQ minus D. Now we will multiply P and Q. So 2AP plus DP square minus DP equal to 2AQ plus DQ square minus DQ. Now these terms, like terms, will come on the same side. 2AP minus 2AQ plus DP square minus DQ square minus DP plus DQ equal to 0. Now make pair of two terms and take out common. From first two terms, common will be 2A, and the remaining variables are P minus Q. From second two terms, the common will be D, and the remaining variables are P square minus Q square, minus common will be D. Even minus you have take out as a common. Whenever you take out minus as a common, the sign of the number will change. Here minus is P, so P will become positive. Q is plus, so Q will become minus. The sign will change whenever the minus is common, equal to 0. Now you can see you cannot do anything further in this. In second term, D into P square minus Q square, you know P square minus Q square, you can factorize it further. a square minus b square is a plus b into a minus b. Same way, p square minus q square equal to p plus q into p minus q. So 2a under bracket p minus q plus d p minus q p plus q minus d p minus q equal to 0. Now you can see in every term p minus q is right common. So p minus q, you have to take it out as a common. So the residues are 2a in the first term plus in second term d into p plus q, d into p plus q. So you can multiply. You can write dp plus dq. In the third term, only minus d is left. So equal to 0. Now p minus q into, now there is nothing common in this all, but then to first number I'll keep as it is. In second 3 you can see d is common, d is common. So d I can write common outside also, in front of the bracket or behind the bracket. So this time I will write behind the bracket, because in concept we are writing every time behind the bracket. Behind the bracket, d we are writing behind the bracket. So here when d is removed, p left, plus here d is removed, q left, minus d is removed, nothing left. Nothing left means d into 1. So 1 is left, equal to 0. Now you cannot further simplify this. It means product of these two numbers or variable is 0. When product of any two number is 0, that means one of them is 0. It means p minus q equal to 0 or 2a plus p plus q minus 1 into d equal to 0. If p minus q equal to 0, then p equal to q, right? Or this will remain as it is. So I'll mark it as 4. This one I'll mark it as 4. Now p minus q equal to 0, then p equal to q. But we know p upon q, p equal to q, p is not equal to q, but p is not equal to q, which is given. Therefore p equal to q is discarded. So this first condition, which is p equal to q, is discarded. Hope you understood how p equal to q, because q will go on that side of equal to, p minus q will go there, becomes p equal to plus q. But it is already given that p is not equal to q, therefore p equal to q is discarded, and this is accepted. 2a plus p plus q minus 1 into d equal to 0 is accepted. Now since we know this thing, sum of p plus q, because we have to prove this as 0, right? So sum of p plus q is p plus q by 2 into 2a plus, okay, I made a mistake here. The mistake was, it's 2a plus n minus 1 into d. What is n? N is p plus q. So here p plus q minus 1 into d will come. So here p plus q will come. So 2a p plus q minus 1 into d from 3. S of p plus q will remain same. P plus q upon 2 also will remain same, into value of these is 0. Now from where you got this value is 0? From 4. We'll just verify from 4. See, 2a plus p plus q minus 1 into d, which is 0, Now you know anything multiply with 0, is 0. So therefore sum of P plus Q equal to 0, and hence proved. That's all. Sum number 13, which is of 3 marks. This sum is just like 12th sum. If you know 12th sum, 13th sum will be very easy. Now we will write given first. M times mth term of an AP is equal to n times nth term. M times means multiply. Mth term, that is T of M, equal to n times, that is n into nth term, that is T of n. Show that, to prove, m plus nth term of an AP. So T of m plus nth term is 0. So term m plus nth term is 0. Now in 12th sum we were using sum property, S of n, S of p, S of q, S of p plus q. Here we have term property, term. So proof, we will start with for n AP, T of n equal to a plus n minus 1 into d, and this is formula. Now what are the terms? M and then n, m and then n, and then m plus n. Now see, n is already there, so we should not use n now, right? T of m, when n equal to m, so instead of m we have to use n, instead of n we have to use m. So T of m equal to a plus m minus 1 into d. And when n equal to m plus n, third one, m plus n, therefore T of m plus n equal to a plus m plus n minus 1 into d. So instead of n what we have to write? M plus n. Okay, now we'll mark this as 1, mark it as 2, and mark it as 3. Now since m times the mth term, T of m, equal to n times nth term, which is given. So m times mth term, what is mth term? A plus m minus 1 into d, n times nth term. And what is nth term? Nth term is a plus n minus 1 into d. M into a plus, now multiply, d into m, dm, alphabetic order wise, d into 1, d, n will remain n, a, d into n, dn, minus d ones are d. Now multiply, a m plus dm square minus dm, a n plus dn square minus dn. Now again these all terms will come here, a m minus a n plus dm square minus dn square minus dm plus dn equal to 0. A, now what you have to do? Make pairing. You have to make pairs and take out common. So in first pair, common will be a, m minus n, plus in second pair common will be d, m square minus n square. In third pair common will be d, Now minus is also common, so you know the sign will change. It becomes m minus n equal to 0. A m minus n plus d, m square minus n square is m plus n, m minus n. Identity, m square minus n square is m plus n, m minus n. Minus d, m minus n equal to 0. Now what will be common? The common will be m minus n, m minus n, m minus n. As m minus n will be common, so a plus, now multiply, these two terms are left. So dm plus dn minus what is left? Only d equal to 0. M minus n, a plus, now you know d is common. D is common in all three terms. So m plus n minus 1 into d equal to 0. So m minus n equal to 0, or a plus m plus n minus 1 into d equal to 0. Therefore m equal to n, or we will keep this same, a plus m plus n minus 1 into d equal to 0. But m is not equal to n. Here there is a mistake. You have to write, since here in the question itself they should give m should not be equal to n, since m is not equal to n. So as m is not equal to n, therefore m equal to n is discarded. Therefore what part is left? A plus m plus 1 n minus 1 into d equal to 0 is accepted. And we will mark this as number 4, I guess, number 3 and number 4. Now from 3 and 4, since t of m plus n, we need to prove t of m plus n is 0, equal to a plus m plus n minus 1 into d. From 3, a will remain a. Okay, no, a will not remain a. A plus m plus n minus 1 is 0, into d is 0. This part is 0. See, this value is 0. From 4. Therefore, t of m plus n is 0. Hence, proved. That's all. This is sum number 13. Sum number 14, which is of 3 marks. It is just like activity sum. 1000 rupees is invested at 10% simple interest. Check at the end of every year if the total interest amount in an AP, right? If this is an AP, find the interest amount after 20 years. For this, complete the activity. Simple interest formula, we know it is P into N into R upon 100. Simple interest after 1 year will be, principal is 1000 which is invested, rate is 10%, so R is 10, and number of year 1, because we need to find for every year. So 1 upon 100, 0 0 0 0 got cancelled, right? 1 0 1 0 1 0 1 0, so 100 ones are 100. So the first box you have to write rupees 100. Then simple interest after 2 years, again 2 years, the numbers are same. Now this is of second year, 2 years, second year, so it will be rupees 200. Now simple interest after 3 years, 3 years will be 1000 rupees into 10%, but number of years are now 3 years, so it will become 300, right? So according to this simple interest for 4-5 years, see, first year it is 100, second year it is 200, third year it is 300, so fourth year will be 400, right? Fifth year it will be rupees 500, and sixth year it will be rupees 600, and so on. For this, the difference is every time rupees 100. And how 100 do you know that? 200 minus 100. 200 minus 100 is 100 rupees. And what is the first first amount or first term? First term was of simple interest was 100. First term of simple interest was 100 rupees. Now, amount of simple interest after 20 years. So T of n, that is the general formula, a plus n minus 1 into d, T of 20, because 20 years, a. And what is a? 100 rupees, 100, or I'll just write 100 plus 20 minus 1 into difference. And what is difference? Difference is also 100. So now simplifying 100, 20 minus 1 is 19 into 100. 100 into 1900. So it will become 2000. So amount of simple interest after 20 years is rupees 2000. Isn't it easy? And this is the end of 14th sum. And we completed your problem set as well and your chapter arithmetic progression as well. Hope you have no doubts.